Right, this is a holiday program day one. This video is for level 3 calculus students in New Zealand. And this is, we want to cover the differentiation achieved level skills today. And then tomorrow I will share the integration skills. Right, so that today you always see this kind of graph question in exam because this is a really important part of calculus. You really need to understand what the continuous mean, differentiable mean, and then limit means, that sort of stuff. So the first question is for the function above, which is on the left for this screen. What where fx is continuous but not differentiable. Let's go over what the continuous means and not differentiable means. Okay, continuous means we can say that a function is continuous at the point if we are able to graph it without lifting the pen. So when you're tracing the graph like this, you're not lifting the pen up. So which means this area, range, this one is continuous, but you need to lift the pen up here, isn't it? Because this is hollow, which means we are not including the value at this point. So lifting the pen up so that at negative x equal -2, this graph is not continuous. Okay, and then going there, continuous, and then this is not continuous, and then continuous, 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 but there is a jump here, which means you can't trace the graph. So this is not continuous, and then continuous, 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 in continuous, 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 including the sharp corner. Okay. Then let's talk about the not differentiable. So not differentiable means, okay, if it's not continuous, which means not differentiable. Okay, then this is the first point that's clear. But the reason for that is by differentiating, you can find the gradient of the tangent, isn't it? Which means if you can't find the gradient of the tangent, you can't decide the tangent at that point of the graph, that means it's not differentiable. What I want to say is if you look around this point, you look at this point, the tangent is going to be like this, isn't it? So if you can draw a tangent line, only one tangent line, and you can find the gradient, that means differentiable. Okay. However, at this point, can you draw a line, the tangent line here? You can't, isn't it? So this means this part is not differentiable. And then this is the most tricky part, this part and this part. You can sort of draw a tangent line like this in your head, but can you decide the gradient of this one? If the line is flat, that means gradient is 0. But if the line is like this, that means the difference of x is 0 and then difference of y is like that. So that we can't have 0 in the denominator, which means when the tangent line is vertical, that means not differentiable. Okay, so then we go back here. These are another point that you can't differentiate because you can't draw a tangent line. So if you look at this one, you can see you can draw tangent at this point, but this point you can't draw one tangent line, isn't it? Yeah. Then this point as well. This is why when it's not continuous, it's not differentiable, and obviously we can't make a line, tangent line here. And another stuff is here. Can you draw a tangent line at this point? You can't decide only one tangent line here, isn't it? Which means if there is a sharp corner, we can't differentiate at this point. Okay. Yeah. All right. So let's go back to the question. Yeah. So the answer is shows here, but anyway. So if you look at this one, continuous, and then this is not continuous, and this is not continuous, but otherwise all the graph, oh yeah, the continuous, isn't it? However, at this point we can't differentiate, isn't it? Okay, so that's why the answer is x equal 5. Okay, the next question is for the function, find the value of x when f dash x is 0, which means the gradient of the tangent is 0, means flat, isn't it, as I mentioned just before. So there is, at this point, the tangent of the graph is going to be flat, stationary. So that this one is if f dash x equals 0. Okay, so that one is one of the answer, but there is another one. If you draw a tangent and the graph of the tangent here, it's gonna be flat, isn't it? Which means from here to here is also, from here to here is also satisfied this criteria. Okay, okay, so the answer is x equal 1 and then 3 and 5. The domain is from 3 to 5, not including that point, right? Next, then number 3 is limit. Okay, when limit is negative, approach to -1, do we have the value for it, or do we, if it's not existing, and then you have to state it's not existing. And let's go to the next slide. Right, so the limit exists if if the value is approached from left and right at the point, and then arrive at the same point, and then that's you can say the limit exists. But if it's infinite, you can't really say this is a, the limit is exist. Okay. What I want to say, okay, that I just go back to some question. So for here, for example, at this point, limit exists because if you approach from left and right at this point, you are arriving at the same point, which is x equal -2, y equal 2. Okay, whereas this point, limit is not existing because if you approach from here and then from left and from right, it's totally different value you get, isn't it? So in this case, it's not existing. Okay, so that let's go to figure out the answer. Yeah, so this one is at which point we are looking at -1, isn't it? Which is here. So if you are going close from right side and the left side, you're approaching to the same point, which is y equal 1, isn't it? So that this value must be, the answer, the value must be 1. X equal 1 is no, y equal 1, and this is incorrect. So I mean limit is 1 is the answer. Okay, so this one This one you don't need to write. No, x equal 1 is not the answer. 1 is the answer because the value of this one becomes 1. Right. Okay, so that I will change the ordinary setting from now so that you can work on, you can see the explanation for these 4 more questions. Okay.